Hello everyone, I hope you all are fine and are doing well. We have completed the 10th chapter, that is basic geometrical ideas. We learned that geometry is a part of mathematics just like arithmetic and algebra. We started the chapter by learning about the meaning of point. We learned that a point represents a fixed location and we can represent point by using any capital letter of our choice. We learned that there are two types of points, collinear and non-collinear points. What are collinear points? When three or more points lie on the same line, they are known as collinear points. Non-collinear means the opposite of it. When three or more points do not lie on the same line, they are known as non-collinear points. Now, after we learned about point, we learned about line. We learned that line is a collection of points and it can be extended endlessly in both the directions. Now, since we can extend it in both the directions, we cannot measure a line. We learned about four types of lines: parallel lines, intersecting lines, perpendicular lines and concurrent lines. Now, what are parallel lines? When two lines never intersect each other even after extending them up to an infinite length. The distance between two parallel lines always remains constant. So, here we have two parallel lines PQ and RS. Next, we learned about intersecting lines. When two lines intersect or meet each other at a common point, they are known as intersecting lines. So, here we have an example. Line AB and line CD are intersecting at a common point Q. Next, we have perpendicular lines. Perpendicular lines are also intersecting lines, but here we have a condition. Perpendicular lines intersect each other at a right angle. That means the angle formed between the lines will be equal to 90 degree. So, here we have an example. Line LM and line NO are intersecting at a 90 degree angle at a point A. Last, we learned about concurrent lines. When three or more lines intersect each other at a common point, they are known as concurrent lines. So, here we have line AP, line TR and line UV, which are intersecting at a common point E. Now, after learning about line, we move to the next topic of line segment. We learned that line segment is a part of line which has two fixed endpoints. Now, since the endpoints are fixed, we can measure a line segment. After that, we learned how can we measure a line segment. We learned about three techniques. First, by observation, second by tracing, third by using a divider. Now, how can you measure a line segment using observation? Now, this technique is used to give a rough idea that which line segment is greater or which line segment is smaller. Similarly, the method of tracing, we use a tracing paper to observe the measure of a line segment using the tracing method, and we can also measure the line segment using a divider. Now, divider is similar to a compass, but in the divider on both the ends we have a needle. After learning about line segment, we learned about ray. We learned that ray is a part of line which has an initial point, that is the starting point, and we can extend the ray up to any distance from one side. So, here we have a ray UV. There is an arrow on one side and a point on one side. So, wherever the arrow is, I can extend my ray from that end. After that, we learned about a plane. A plane is a 2D shape which can be represented using three or more collinear or non-collinear points. Next, we learned about angles. We learned that an angle is formed using two rays or two line segments. Under that, we learned about interior and exterior of an angle. Now, what is interior and exterior of an angle? Everything which is enclosed within the arms of an angle is known as interior. So, for example, I have an angle over here. I am naming this angle as PQR. So, the area which is enclosed within the arms of an angle is known as interior, and everything which is outside and not enclosed by the arms is known as exterior of an angle. Next, we learned about magnitude of an angle. Now, magnitude of an angle is similar to the measure of an angle, that is degree. We represent the measure of an angle in terms of degree. Next we learned how to measure an angle. We learned that we can measure an angle using a protractor. Now protractor is in the shape of a semicircle. Now when you have to measure an angle, you place the protractor on the angle in such a way that the baseline of the protractor should overlap the base ray, and wherever the second ray is lying on the protractor, that will be your magnitude or measure of your angle. Further we learned how we can compare two or more than two angles. We can use three techniques: by observation, by tracing and by measuring. Now under observation we should know the types of angles. We learned about acute angle, right angle, obtuse angle, reflex angle, straight angle, complete angle and zero angle. So just by observing you can tell that an acute angle is smaller than an obtuse angle. A reflex angle is greater than a straight angle. Next, for the method of tracing, again we will use a tracing paper and place it over the first angle, trace it accordingly and then place that tracing paper on the second angle. And for the method of measuring, you need a protractor so that you get an exact magnitude or measure of your angle so that you can compare which angle is greater. Last, we learned about the topic of curves. Under that, we learned about two types of curves: simple curve and complex curve. Now, what is a simple curve? When you are making a curve without lifting your hand, that is known as a simple curve. What is a complex curve? When you are making a curve but the curve crosses each other, that is known as a complex curve. Next we learned about open and closed figures. Now open figure, the starting point and end point is different, but in a closed figure the starting point and the end point is exactly same. Under the topic of angles, we learned about two more topics, that is how to represent angles in the term of revolution and in the terms of direction. Now what is one complete revolution? One complete revolution means one complete angle that is equal to 360 degree. So for example, in a clock you are moving from 12 and you reach 3. The arms of the clock, it started from 12 and it is going up to 3. Here we can say that 90 degree angle is formed. Now how do we represent 90 degree angle in terms of revolution? We can say that 90 degree is equal to 1/4 of a revolution. Similarly, you can represent other degrees also in terms of revolution, like 180 degree is half of a revolution. Next we have in terms of direction. Now you know that we have four directions: north, south, west and east. Now when I move from north and I go to south, I have taken 180 degrees. So this can be represented as half of a revolution. So we can say that when we go from north to south, we can represent it as 180 degree, or we can also present it as half of a revolution. So students, we have covered all the topics in the chapter. I hope you have understood the concepts. Practice the questions given in the textbook. I will see you in the next interactive session. Thank you and have a nice day.